Hello and welcome back to Database Management Systems. I'm Jivita Christie, and in the previous video, I had explained part of this ER diagram, and especially I'd explained the course and the course depth relation with department. I had also explained that this part right here, that is course and prerequisite, that is a recursive relationship, and I had explained about instructor being related with student through the advisor relationship. And now we're going to see the rest of the ER model. And to see that, let's go ahead and just, check this out. Check out instructor with department, how it is related. So here you have instructor right here, and it is as we know, it is borrowing the department name from the department relation. Now, sometimes, as you must have noticed, like when there's a student and instructor given, there is also a relation given here, and you simply converted this into a relationship set. That was all right. But when you see department and instructor, there's no extra relation given to connect the two. You're simply just attaching its department name with this. So in this case, you're not going to create a relationship set. You're just going to convert it into, in this case, you're going to create a relationship set of your own when it's not given, because two entities cannot be connected with each other directly without the use of a relationship set, which is why we are going to create a relationship set. You can see right here, instructor, department, and again, I cannot think of a creative name to give it, so I'm just going to name it inst underscore depth. It's all right. It doesn't always have to have a name like advisor and teaches and takes. Okay. So again, whatever is connecting instructor with department, that is the department name within instructor. And now, as you'll notice that some attribute is missing. See. Here, instructor is having 4 attributes: ID, name, depth name, and salary. And department is having depth name, building, and budget. Now you go there and check it out. Department is all right. It's having depth name, building, and budget. Instructor is also fine. It has ID, name, and salary, but it does not have depth name, because that relationship that it has with department is already included here. So already ID is connected to depth name from here. So those things are already created here. So you don't have to include depth name here also. That's not required now. Now, another thing, every instructor belongs to some or the other department. So there's a total participation, right? But we might have departments that do not have instructors, and maybe they're departments for support staff or whatever. So which is why we are not creating a total participation here. And one more thing is, every instructor belongs to only one department, but one department can have many instructors. So which is why this is a many-to-one relationship from instructor to department. Okay. So this part is done. Now, just like instructor belongs to some department, student also belongs to some department, and we can go ahead and look at it here. This is the student, and this student also belongs to the department right here. Yes, this is the student, and the student belongs to the department. It is connected in this manner. So depth name from here is connected here. But once again, there is no extra relation between the two. So we are going to create that while converting into an ER diagram. And at the same time, we are going to remove this depth name from student, because that relation will be present in the relationship set. So you can see that there is no depth name in student here. And we've simply named it as stud underscore depth, and we are connecting it again. Each student would belong to only one department, and each student would belong to some department. So that is why, again, this is total participation, and it's a one-to-many relationship if you look from department to student. If you're looking from student to department, it's a many-to-one relationship. So this part of the rhombus is over. Now the bottom part of the rhombus. To understand that, let's first understand what section is, right? So section is formed from course, and we're going to see that right here. Let us see how section and course are connected. So this is section and this is course, right? The only connection between them is the course ID. The section is using a course ID and course is also using a course ID. So section is borrowing the course ID from there. Now, there will be several sections. A section essentially is assigning a room or a classroom for a course. And we all know that it's not always possible that there's only one classroom for the given course. There can be several classrooms for the given course. So which is why, because the capacity of the classroom is not enough to hold all the students taking the course. So you might have to divide it among different classrooms, which is why we have created section here. And here you have section containing course ID, which is borrowed from course. Now we know that this course ID would be repeating several times because the same course is being taught in several classrooms. So that is why we have created a section ID and we have created semester, year, and all these things are there. And what this basically means is that section does not have a primary key of its own. If you look at all other tables here, if you look at all of the relations, they have some or the other primary key unless they are, relationships. Like advisor does not have a primary key because it's a relationship. Prerequisite is a relationship, so that's different. Takes is a relationship, it's different. But this is not a relationship, it's an entity set. And yet it does not have a primary key of its own, which is why it is a weak entity set right here. This section is a weak entity set. So that's why when you are connecting it with course, you are going to create this type of a double rhombus. There are two ways to show a weak entity. You can either create a double entity, that means create a double rectangle here, or you create a double rhombus. Double rhombus is fine. And whenever it's a weak entity set with a strong entity set, this one, that is the weak entity set, always totally participates. So this is total participation. And it's always a one-to-many relationship from the strong entity to the weak entity. Now you can see several attributes from section are missing. We have only included section ID, semester, and year. So there's only section ID, semester, and year. The rest of the things are gone. Why they are gone? Because building and room are taken from classroom. And so we will show that using a relationship between section and classroom. So classroom contains building and room number, but section does not, because that relationship will be shown in sec_class. And again, every section belongs to some class. So this is a total participation, so double line. And every section belongs to only one class. So that's why this type of a thing. There's an arrow here. Okay. And the same thing you can go ahead and see for section and time slot. For section and time slot right here. This is section, this is time slot. Time slot ID is borrowed from here. So if you look at it, what we have done is created this type of a relationship sec_time_slot, and this is a total participation. This is the side called one. So this is again one to many from time slot to section. And this is slightly different. Everywhere else attributes are directly written, but here there's this curly bracket, and day, start time, and end time are mentioned inside the curly bracket. The reason is this is sort of what I'd say complex attribute or composite attribute. This is like creating name and then first name and last name. It's a composite attribute. So this is also a composite attribute, time slot ID, which is why it is created in this manner. This is composite. Okay. Now whatever is remaining, that is instructor is connected with section using teachers, and student is connected with section using takes. Both are teachers and takes, both are available here. This is takes and teachers. Now see, teachers is borrowing everything from some or the other place. So none of the attributes in teachers belongs to teachers. So you can see here that teachers does not contain any attribute. They are all borrowed from everywhere else. But takes, on the other hand, you can see here that takes is borrowing everything. There's arrows going out from everywhere, but not grade. So grade is actually belonging to takes. So which is why we created this type of a thing. Now this is a descriptive attribute, and because we are using this alternate notation, we are using a rectangle instead of an ellipse, which is fine. The line that is connecting is dashed because it's a descriptive attribute. Okay. So this is what the ER diagram looks like. And now what we're going to do is convert it into a relational model. Okay, so to convert that, first we are going to see how to represent strong entity sets with simple attributes. So simple attributes means attributes which are not composite or multi-valued. They are simple attributes, and these entity sets are strong in the sense they have a primary key inside. So we found out that there are 1, 2, 3, 4, 5, 6 such relations. So now what we are doing is converting that ER diagram into table format. So you can just see student is right here, student, and it contains ID, name, and total credit. Now we are just including that much: ID, name, total credit. This is very simple. Classroom, again, classroom is right here, and it contains building, room number, and capacity. Here the primary key is created using building as well as room number, both together. So that is fine, we took it. Then department is right here with depth, name, building, budget. So that is also taken as it is, nothing new. Okay, then course ID, title, credits. Let's verify. So course is right here. It contains course ID, title, and credits. That is done. Then we have instructor containing ID, name, and salary. So instructor is right here, contains ID, name, and salary, and the same thing is created here. Then, okay, this is just repeating. Sorry for that. You can just ignore that. Okay, so these are strong entity sets with simple attributes. Now let's see what we need to do next. We need to do representation of strong entity sets with complex attributes. So what that looks like is we have not included all this. This is just an example. So as you can see, suppose you had instructor with middle name, first name, and last name. So this would be a composite attribute. So what you would do is, instead of storing name, you would store its composition, that is first name, middle name, and last name. Suppose instructor had an address that contained street number, street name, apartment number, city, state, zip code, maybe all these are compositions. Then again, you would store the compositions and not the main thing. If suppose instructor had a phone number, now phone number is a multi-valued attribute. So when you convert it into a table, what you would do is you do instructor underscore phone. You are creating another separate table for that, and you would make it ID comma phone number. Now our ER model does not contain this type of these types of attributes, but this is just for your information. Okay, we can see that instructor right here in our ER model does not contain all those things. So that's okay. You don't have to worry about that. Okay, now time slot, we saw earlier, and I also specified that it is a complex attribute. That means it's combined with and made using something. So that's why, again, We are just listing out everything. Time slot ID, day, start time, and end time. That is what it looks like. The next thing we have is representation of weak entity sets. There's only one weak entity set here, which is section. So section contains section ID, semester, and year. But when we are creating a table, we will add course ID to it, because course ID is the primary key of the strong entity set to which section is attached. So whenever we are representing a weak entity set, we have to make sure that we are taking the primary key from the strong entity set and putting it in the weak entity set. So this is what it is, okay? The next thing we have is representation of relationship sets. Now this is a little bit tricky, but it's not so difficult actually. Okay, let's get started. So let's begin. The first relationship is teachers. So how did we create teachers? Teachers is right here. Okay, it's here. Now it's a relation between instructor and section. So what we will do is whatever is underlined in section, that is section ID, semester, and year, will go to teachers, because section does not, it's a weak entity set and does not have a primary key. So in order to form a primary key, we have to include these attributes, and from instructor we'll take the primary key because it has a primary key. And because section is a weak entity set, we have to include course ID, which is the strong entity set to which it is connected. So we can see right here, we have included course ID, section ID, semester, year, and ID. And for takes, what we have done is, let's take a look at takes. Takes is right here. So takes contains its own attribute, grade, plus it is connected to section. So for section, we have to take section ID, semester, year, and course ID. And from student, we will only take ID because it's a strong entity set. So you can see right here that again, from student, we have taken only ID, and then we have all these attributes, which I said. Prerequisite is a recursive relationship. So for recursive relationships, we are not doing much. For recursive relationships, we are simply including it. So prerequisite is here. So whatever two things are connected, we are just including them. And I'd like you to take a look at advisor also. Advisor does not have its own attribute, plus it is connecting a strong entity with strong entity. So we'll just include this ID and this ID. Now we cannot name both attributes as ID. That is very confusing. So we will just rename this ID as maybe IID and this as SID. So you can see here, that's what we have done, SID and IID. Okay, then we have sec_course. So sec_course is done in this manner, which is first of all here. So we will include all these attributes of section plus course ID. That is what sec_course looks like. So right here, course ID, sec ID, semester, year. Sec time slot. So for this again, we are including everything from both. Sec time slot, which is right here. So we will include everything from section along with course ID and then time slot ID, which you can see here. So there is course ID, section ID, semester, year, and time slot ID. Now sec and class. So for sec and class, which is right here, we will include everything from section along with course ID, and from classroom we will take building and room number because both are forming the primary key. So both the things are included. Okay, right here, course ID, section ID, semester, year, building and room number both. Okay, inst depth is given here. So you can see it is connecting these two. Both are strong entity sets, both have primary keys. So just include primary key ID and depth name. So you can see that right here, ID and depth name. And then you have stud and depth. So this is given here. It's connecting department and student. So again, both are strong, both have primary keys. So ID and depth can be simply included here. And finally, course and depth. So course and depth is connected course with department, and course is right here, and course connected with department up here. This is course depth. It will contain only course ID and depth name because both are strong entities and have primary keys. So we'll just include those, course ID and depth name. All right, so that's how we have converted whatever tables we have created. Those are the tables which are belonging to the relational model. If you have any questions, please leave them down in the comments below. Thank you for watching.